Alright, we're going to look at one more example of linear programming problem. The last one we did was a minimum. This one is a maximum, and it's a long problem. It's got a lot of steps to it, as you may remember. In the previous videos I broke the steps down into, I think, 4 different parts, but here I'm going to try to do all 4 parts in the same problem, hopefully all on the same whiteboard here. A manufacturer produces 2 sizes of handbags. It takes longer to cut and dye the leather for a smaller bag, but it takes more time sewing the larger bag. The production constraints and profit for each type of bag are given below. And as you can see in this little table, cutting and dyeing one of the large bags takes 0.6 hours, a small bag 1 hour. Sewing takes 2 hours for a large bag, 1.5 hours for a smaller bag. And you can see the profit here, $30 profit for the large bag, $25 profit for the smaller bag. The machine limits the number of bags produced, because these are not cut typically by the human hand, they're usually done by machines. The machine limits the number of bags produced to at most 1,000 per week. If the company has 900 hours per week available, that's labor hours, available for cutting, dyeing, and 1,800 hours available per week for sewing, determine the number of each type of bag that should be produced weekly to maximize profit, and we're going to assume that all the bags produced are also going to be sold. Now if you're saying, well, there's only 168 hours in a week, well, we're talking about maybe several machines here, and so it adds up to 900 hours per week, 1,800 hours available per week here for the sewing aspect. So what we're going to do is we're going to first come up with our objective function, which is going to be our profit function here. And again, the textbook uses Z. I typically, when I do profit, I use a capital P. I mean, if you want to use a capital P and write it as the profit involving the independent variables X and Y, well, I tell you what, maybe I'm jumping the gun a little bit. Maybe I should say what X and Y are. Well, we'll let X represent the number of smaller bags, and you can make X the larger bags, and Y the number of larger bags. Now I can go ahead and write my profit equation in terms of those 2 independent variables X and Y. Since I make $30 a large bag and $25 a small bag, this would be 25 times X, the number of the small bags, $25 profit each time, and $30 for the large bag, 30 times Y. That's my profit equation. This is what I'm going to try to maximize right there. So I don't want to lose track of him. Now I have a number of constraints, some based on the actual production, some based on the number of hours available. So I'm going to have, first off, since X and Y represent the number of bags, I think you will agree that X has to be greater than or equal to 0, and Y has to be greater than or equal to 0. If you're looking at my graph over there, you can see that I've got that set up where it's predominantly in the first quadrant. Now, I need to see the other possibilities. So what do we have here? We're going to produce at most 1,000 bags per week. So that would mean that X plus Y, the number of the small bags plus the number of the large bags, can be no more than 1,000 bags per week. And we also have to bring in the constraints that we have due to the actual production here. Now remember, each bag, each small bag, each large bag, X and Y, we have how much time it takes for the cutting and dyeing, how much time it takes for the sewing, and we have caps here for the cutting and dyeing, and here for the sewing. So if I have X small bags and Y large bags, each small bag is multiplied times 1 hour for cutting and dyeing, and each large bag is times 0.6 hours for cutting and dyeing. So I'm going to have 1x, which I don't really need the 1, I'm just putting that for emphasis, plus 0.6 times the number of the larger bags, and this is for the cutting and dyeing, and this can be, let's see, 900 hours available, so it has to be less than or equal to 900 hours. Similarly, again, X and Y here. For the sewing, each small bag, 1.5 hours takes for sewing. Each large bag, 2 hours, so 2Y. And if I add those together, that has to be under 1,800, less than or equal to 1,800. I'm going to go ahead and just get rid of that 1. I don't really need that there. And I believe that is the list of constraints that I'm going to have to work with. Now, with these constraints, I'm going to go over here to my graph, to my set of axes. I'm going to graph these inequalities. Now, of course, the first two here, that's just quadrant 1. So I'm really only going to concentrate on these three. And I think I'm going to try to do these in different colors so that I can keep them organized a little bit better. I'm going to write this first one here as an equation. X plus Y is equal to 1,000. Alright, so let's see. If this is 100, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be 1,000. This would be 1, 2, 3, 4. This would be 500. 11, 12, 13, 14, this would be 1,500. 16, 17, 18, goes up to 1,800 that way. And let's see, 2, 3, 4, 500 here. 6, 7, 8, 9, 10, 1,000 here. 11, 12, 13, 14, 1,500 here. Alright, so now I'm going to graph this line. Now this line has an x-intercept at 1,000, 0, and a y-intercept at 0, 1,000. So I'll do this one in black here, and it's going to go through these two key points right here and right here. Okay, draw the line here. Now, I'm going to pick a point that's not on the line like 0, 0. I'm going to go back to the original inequality and put 0 in for x and y, and it's true. So that tells me I am shading this way. I'm just going to go ahead and write that for right now, that I'm shading this way. I don't want to try to blacken it all in, it'll be a mess. I'll do the next one here. That was this one right here. Right here. I'll do the next one here in blue ink. So I'll write it as an equation. This would be x plus 0.6y equals 900. Now, some students aren't really crazy about decimals. You can multiply through by 10 if you wanted to, divide through by 2 after that. It's kind of up to you and how you want to go about to do this. I'm just going to kind of leave it as is, and since it's in standard form, I'm going to find my x and my y-intercepts. My x-intercept is when y is 0, so that'll be right here at 900. My y-intercept is when x is 0, so if I divide 900 by 0.6, if I'm not mistaken, I believe it's 1,500. Okay? So I'm going to get my straight edge here, and I'm going to draw this line. It goes through those 2 points. Hopefully my straight edge won't shift. That looks pretty good. And I pick a point not on it, like 0, 0, which is clearly to the left. Plug 0, 0 in here. This would give me 0 is less than or equal to 900. That's looking good. I'm shading this way. And then the last one, I will do this one with a red pen and see if I can keep these straight there. Therefore, let's see, 1.5x plus 2y is equal to 1,800. So again, let's find my x and y intercepts. If I find my x-intercept, y is 0. So I have to divide, let's see, 1.5 would go in 1,200 times, if I'm not mistaken. And if I divide by, if I find my, oh wait a minute, that was my, oh goodness gracious. I'll fix that in a second. That was my x-intercept was at 1,200, that's over here, 1,200, 0. My y-intercept is going to be, when x is 0, it's going to be at 900. So that's down here. Oh, almost messed that one up royally here. Let's see if I can fix this just a little bit. And I'm running out of different pens here. There we go. Okay. And I pick a test point here. Let me draw the line first that connects these two red dots. Now this is why I use graph paper, because even though I've tried to be really good with this, it doesn't take much to mess it up, and you're much better off doing this with graph paper and a sharp pencil. And if I pick 0, 0 and plug that in, which is clearly again to the left, that would give me 0 is less than or equal to 1800. So it's this region this way. So if I look at where these overlap, I think I've got one more color here, actually a couple more colors here. I'm going to get, this is my feasible region. Let's see if I can make this look halfway decent. That's a key point right there. And I'm going to get, that's a key point. I'm going to get something that kind of looks like the Superman emblem a little bit, or a diamond there. It's 5 sides. That means I'm going to have 5 corner points. Now finding these corner points might not be quite as obvious as it was in the previous example, although this one's an easy one. Well, maybe not with this pen. It would be easier with a better pen. Let's see. Yeah, this is 0, 0. And this one here, we know that's 900, 0. And this one here is 0, 1000. But what about this guy and this guy? Now we could approximate them. I mean, this kind of looks like 800, maybe 300, 250. It's kind of hard to say. You may have to solve them simultaneously. So like this one is the blue line and the black line. That's these two. So what I'm going to do, I'm going to solve for y here, or I'm going to solve for x here. X is equal to 1000 minus y, and then I'm going to plug this in and solve the equation simultaneously. 1000 minus y plus 0.6y equals 900. This is negative 0.4y equals negative 100. Y is equal to 250, which is, 100. Y is equal to 250. So I was right, this does look like about 250, so maybe my graphing is better than I expected it to be. Well, what x value would go with that? Is it 800? Is it 700? Is it 750? Well, let's go back to this equation and plug 250 in. That would give me an x would be 750. So this point right here, this key point, this corner point, would be 750, 250. One more. Now this guy up here looks like it could be 400, 600, but again, it's kind of tough to tell. That's the black line and the red line. So I've already set this up for a substitution once before. I'll do it again. Plug it right into there. 1.5 times 1000 minus y plus 2y is equal to 1800. This is 1500 minus 1.5y plus 2y is equal to 1800. Combine like terms. I get 0.5y plus 1500 equals 1800. Subtract 1500. 0.5y equals 300. Divide by a half, and I get 600. So I was off a little bit here. This guy right here, this key value, turns out to have a y value of 600. To find the x value that goes with it, plug 600 in here, and x turns out to be 400. Now, I have my 5 corner points, and I'm going to see which one is going to maximize my profit here. So I have to go back to my objective function, which is my profit function down here, and I have to plug in those 5 guys. Well, I'm going to plug 0, 0 in, even though making 0 bags of each type is not going to get me any money. But I'm going to find, here, I'll put it down here. I'm going to find P of 0, 0, P of 900, 0, P of 750, 250, P of 400, 600, and P of, let's see, 0, 1000. So I'm plugging them into here, 25x plus 30y. So this would be 25 times 0 plus 30 times 0 is 0. Not much money there. This would be 25 times 900 plus 30 times 0, 25 times 900. And let's see if I've done this one. I have 27,500. I kind of did this ahead of time. This next one, I'm going to plug this one in. This would be 25 times 750 plus 30 times 250 is going to give me a grand total of 25,000 on the nose. So right now, the leader in the clubhouse is 27,500. That's the biggest profit so far. I can knock this one out. I can knock this one out. I'll plug in 400, 600. This would be 25 times 400 plus 30 times 600. Let's see, that's 10,000. 18,000, that's 28,000. Well, we have a new leader. It's no longer 900 because that's a little bit more, $500 more. Let's see if the last one helps or hurts. Let's see, 1,000, so that's 25 times 1,000. Oh, times 1,000. Try that again. Times 0. Oh, wait a minute. Heavens to Betsy's. I'm glad I looked. That's a 900. There's 1,000. My goodness. I almost did all that work and I would have had the wrong answer. So now this would be times 0 plus 30 times 900. I wonder how many of you are watching me do this were talking to the video and saying, no, you did it wrong. That's not 1,000, it's 900. Well, I found it now. And that is 27,000. So there's our guy. Now the question says, how many of each type of bag should be produced to maximize profit? To maximize profit, the company should produce and sell 400 small bags, remember X for the small bags, and 600 large bags. And that would give us a maximum profit of $2,800, and that is, or $28,000, excuse me, and that would be the profit for the week, which is pretty good profit as far as I'm concerned. $28,000 attained from 400 small bags and 600 large bags. Okay, all that problem, I did everything right except I got careless and I put down the wrong ordered pair. And if I hadn't caught it down here, I would have had the wrong answer for sure, because 1,000 here would have given me $30,000, and I would have indicated that that was the exact or the correct answer. So be very careful. I wish I could say I did that on purpose just to show you how simple it is to make a mistake, but I got careless, so you need to be extra careful and focused as you're working these problems. And as I've said before, and we'll say again, practice, practice, practice.